So I'm going to add and subtract scientific notation values. Let's say I got 4.23 times 10 to the minus 4 plus 2.43 times 10 to the minus 4, right? Okay, so the idea of adding and subtracting scientific notation is that the exponents need to be the same. So we'll take these values, okay, and then we're going to add. So 3 plus 3 is 6, 4, 5, 6, another 6, here's a decimal, and then, wow, okay. So that was pretty straightforward, right? Then 6.66 times, these have to be the same, the exponents. So 10 to the minus 4. Let's do that here. So before we start, let's put it into a scientific notation mode, which I just move over to scientific notation, enter, quit. Okay, now it's in that mode. 4.23 double E for exponent, minus 4, not take away 4, plus 2.43, right? Double E. Not all calculators have double E, by the way, but this one does, to the negative 4, equals 6.66 times 10 to the minus 4. Okay, great. Let's try another one. And you'll see why we do this one. 4.543 times 10 to the 4th, and 8.627 times 10 to the 4th. So these are the same, right? Times 10 to the 4th. And we're going to add 4.543 and then 8.627, right? So we're going to be, this is 10 times, whatever number times 10 to the 4th. So we're going to add these numbers, okay, add. So that's going to be what, 10, 4, 5, 6, 7. This is going to be what, 10, 11, decimal, 12, 13, right? 13.170. So 13.170. We want this decimal, right, to be in the ones place. So the idea here is if I move the decimal to the left, I'm making the number smaller. And I'm going to have to make the exponent bigger. It would be the same thing. If I move the decimal to the right, I'm making this number bigger. I'm going to have to make this decimal smaller. So because I'm moving the decimal to the left, I'm making the number smaller. And so I'm going to have to make the exponent bigger. Because I'm moving one place to the left, I'm going to have to make the exponent bump up one more. Okay, is that right? We'll find out. 4.543 to the power of 4 plus 8.627 to the power of 4 equals 1.317 times 10 to the 5. See that? Okay. And the zero is not here. It has to do with scientific notation, but we're not going to go over that right now. So let's do another one. Let's do 8.84 times 10 to the minus 4. Take away 9.54 times 10 to the minus 4. Again, the exponents are the same. We're going to subtract. Okay, so we take 9.54, 8.84. The subtraction is on the bigger number. Okay, we subtract. This will be 0, borrow, 15. Here I got 10 fingers, right? but this is 15. So we'll pretend we have 5 more. So we're going to drop 5, 5, 6, 7, 8, 7. If you have another way of using your fingers to subtract, that's fine. And then this is an 8, this is a 0, but it's going to be a negative. Okay, because the exponents are the same, right? We're going to put times 10 to the minus 4. But here we got negative 0.70. So this is not bad, okay? Now keep in mind, in the number line, here's 0, negative 1, negative 2, negative 3, negative 4. Remember that negative 4 is smaller than negative 3. Or we can say that negative 3 is bigger than negative 4. Okay, now watch. This takeaway sign, this negative sign, we're not going to do anything with. But I'm going to make this number bigger because I'm going to the right. I'm moving the decimal to the right. I'm going to make this number bigger. Okay? So the exponent is going to have to be smaller. If I'm making a number bigger, I have to make this number smaller. I'm sorry. If I have to make this number bigger, right? If I have to make this number bigger, that's right. If I have to make this number bigger, I'm going to have to make this number smaller. So smaller means negative 5, which is over here. Okay, that's right. Okay. So again, if I want to make this number bigger, right, moving this way, if I'm moving the decimal to the right, which is making the number bigger, I have to make this number smaller. Okay, let's see. All right, let's look over here. So 8.84 times to the negative 4. Take away, right, not negative. Take away 9.54, and then to the power of negative 4. Enter. Negative 7.0, or in this case, just 7. Negative 7 times 10 to the minus 5. Okay, let's multiply and divide scientific notation. Let's say you had 2.34 times 10 to the 4th times 3.46 times 10 to the 4th, right? Ooh, that's a lot of numbers. So the way we do this in terms of multiplying two scientific notation numbers, 4 times 4 would not be the case, okay? It would be 4 plus 4, all right? It's that rule of exponents, right? What do you do when you have the same base? You add the exponents, okay? That's the same rule over here. So this is times 10 to the 8th, all right? Okay, now 2.34, 3.46. Depending on what school you go to, this multiplication might not look like what you do at home or at school. But we're going to do it anyway. This is basically an old way of doing it, I guess. 6 times 4 is what? I don't know, 24. 6 times 3 is 18, 19, 20. So we put the 0 here, okay? And then 6 times 2 is 12, 13, 14. Okay. Put an X here. 4 times 4 is 16. 4 times 3 is 12, 13. 4 times 2 is 8 and 9. Then 2 places more. 3 times 4 is 12. 3 times 3 is 9 and 10. 3 times 2 is 6, 7. Wow. Right? Okay. Then this is 4, 6, what's that? 7, 8, 9, right? 9, 10, 8. And then there's 1, 2, 3, 4 places. 1, 2, 3, 4. So we got 8.0964 times 10 to the 8th. All right, let's find out. Let's see if we can get this. We're going to clear that. 2.34 times to the power of 4 times 3.46 to the power of 4. Enter. 8.0964 times 10 to the 8th. All right. Okay, let's do one more. Let's say 8.4 times 10 to the minus 5 times 2.3 times 10 to the 4th. So 10 to the minus 5 times 10 to the 4th, right? Same base. 10 to the minus 5 plus 4 gives you 10 to the minus 1. Okay, but we need to still multiply 8.4 times 2.3, right? Okay. 3 times 4 is 12. 3 times 8 is 24, 25. Put an X. 2 times 4 is 8. 2 times 8 is 16. All right. This is 2, 8, 9, 10, 11, 12, 13. 6, 7, 8, 9. And this is 1. This is 1, 2 places. 1, 2. So this is 19.32 times 10 to the what? Negative 1. But we need to move this decimal over to rewrite it in the ones place. So what do we do? So we're going to move this decimal to the left. We're making this number smaller. When we make this number smaller, we're going to have to make this number bigger. So 1.932. We're making this number smaller. We're going to have to make this exponent bigger. So that's times 10 to the 0. 0 is bigger than negative 1 at one place. So it could be written like this in the calculator. Usually when you write it, you don't write it that way. But it depends on your teacher. But this is the answer probably on the calculator. Let's see. Let's find out. Maybe not. 8.4 e to the minus 5 times 2.3 to the power of 4. Enter. It does write it. See, it does write it with an e. Because we're in scientific notation, 1.932. So let's do division. So let's say it's 3.21 times 10 to the 6 divided by, and we can put parentheses, divided by 2.21 times 10 to the 3rd, right? So 10 over 6, 10 to the 6 and 10 to the 3rd, the division. So when we take this number and put it up, 10 to the 6 times 10 to the minus 3, the sign changes, and 10 to the 6 minus 3 will give you 10 to the 3rd power. Okay, so 3.21 divided by 2.21, which is 2.21 divided by 3.21, right? And what we're going to do is we're going to move the decimal place 1, 2, 1, 2. So it'll be here. 2 to 1 divided by 3 to 1 with the decimal place right there, right? We could put another 0 here if we wanted to. 2 to 1 can fit easily here, 2 to 1. 1 times 2 to 1 gives you 2 to 1. Or 2 to 1 goes into that, right? We subtract, that gives you 0, 0, and 1. And then you drop the 0 here. And then 2 to 1. How many 2 to 1s go into that, right? 2 to 1, probably, what, 4 times. 4, 8, 8, 8, 8, 4, so 8, 8, 4, 4 times. And then borrow, 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 6, this is 9. That's a what? That's a 1, isn't it? Is that a 1? This is a 9. That's a 1. That's a 0. Right? 1, 1, 6. Right? And then what you can do is you can add another 0. Right? And 2 to 1 go. How many 2 to 1s can go into here? Probably. But let's add another 2 to 1, 4, 5, 8, 9, 10, 8, 9, 10, 11. So 11, 0, 5, right? Gives you 55, borrow. That's 5 times. And we can keep on going. We can add another 0 and keep going. So 1.45 times 10 to the third power. Let's see. So if we turn this on, we can erase that. Parentheses, put parentheses, 3.21, just in case. I don't think it needs it, but we'll do it anyway, to the 6th power. Close parentheses, divided by 2.21 to the power of 3. And yes, you could put parentheses in the bottom as well. Enter. 1.45 times 10 to the 3, times 10 to the 3. And you can see that there's 2 of these values that go into here, and that's why there would be a 2 here, 1.452, okay? And so it's the same thing, you know, what you learned in arithmetic, but you're going to have to deal with the exponential part. And of course, this is scientific notation. All right. Okay, let's do one more. 4.31 times 10 to the 4th divided by 8.34 times 10 to the minus 3. That's a 3, minus 3. So 10 to the 4th over 10 to the minus 3. This one, you move it up. 10 to the 4th times 10 to the 3rd gives you 10 to the 4 plus 3, 10 to the 7th. So this is 4.31 divided by 8.34. Oh boy. Okay, let's see if we can do it. 8.34 divided by 4.31. Move the decimal place over twice. 834 divided by 431. Decimal place here. We can put a 0 here. Okay. That goes up. So what? So 834 won't go into these 3. We're going to have to go through all these. So 834, let's say times 5. That's 20, 15, 16, 17, 41, right? 4170. So 4170. 5 times, because it lands right here. Okay. That's 0, borrow, 1, 1, 2, 3, 4, 5, 6, 7. That leaves you with 4. This is 2, this is 1, that's 0. Right? 1, 4, 0. You can put another 0 here. 1400. That's going to be just one number, 834. 1. Borrow, 3, borrow, 9, borrow, 6, 6. That one's a 3. So borrow. So again, I have 13. This is 13 take away 8. Right? This is take away 2. 13 take away 8. So let's say I had 3 more fingers here. Drop the 3, 4, 5, 6, 7, 8. So it's going to be 5. Or whatever way you want to do it. You can count up 8, 9, 10, 11, 12, 13. You'll be like, that's easier. Yeah. So 0.51 times 10 to the 7th, right here. And we can put a 0 here if we want. Now, we need to move this so that it could be in the ones place. So what do? If we're going to make this number bigger, we must make this number smaller. So 5.1 times 10 to the 6. Make this number bigger. We're going to have to make this number smaller. Okay, let's see. This time I'm not going to use parentheses. This should work out. 4.31 to the power of 4. It's good practice to put parentheses, but let's see. It should work out. Divided by 8.34 to the power of negative 3 equals 5.16 times 10 to the 6. 5.1. We didn't do the 6 because we didn't work out the next value. And that's something that you have to ask your teacher about. Okay, 5.16, and that's it. Okay, times 10 to the 6, as you can see. Okay, so this is dividing and multiplying exponentials. I mean scientific notation, which has exponentials. If you like this video and you got something out of it, please give it a thumbs up. Please subscribe. Please tell your teacher so that they can share it with the class. All right. Now let's do powers and roots. Okay. So let's say we got 2.4 times 10 to the 2 to the power of 3. Okay, so that's like 2.4 to the 3rd times 10 squared to the 3rd. Okay, now this is x squared to the 3rd. When we have this, we multiply the powers. So this is times 10 to the 6. We got that. But 2.4 to the 3rd is 2.4 times 2.4 times 2.4. Okay, so let's do this by hand, right? 2.4 times 2.4. 4 times 4 is 16. 4 times 2 is 8 and 9. X. 2 times 4 is 8. 2 times 4, 2 times 4 is 8. 2 times 2 is 4. This is a 6. That's 10, 9, or 16, 17. That's easier. And then 5. Okay. 5, 7, 6. There's 2 decimals, so it's 5.76. And now I'm going to multiply that with 2.4, another 2.4, okay? 4 times 6 is 24. 4 times 7 is what, 28, 29, 30. 4 times 5 is 23, right? Don't forget to add the 3. 2 times 6 is 12. Let's put an X here. 2 times 6 is 12. 2 times 7 is 14, 15. 2 times 5 is 10, 11. Oh. Multiplying by hand is crucial. 4, 2, I think this was a 3. That's an 8. 2 and 1 is 3, and then a 1. And then we got 1, 2, 3 decimal places. 1, 2, 3. So it's 13.824 times 10 to the 6th power. But we need to change that, right? So if we make this smaller, the number smaller, we have to make that one bigger. 1.3824 times 10 to the 7th. Let's see. Okay, let's turn it on. Let's quit this. So I have to use parentheses. I mean, I want to. We'll do it that way. 2.4 to the power of 2, right? Close it. And then you could square it, but this is not a square, it's a cube. So we're going to have to use this button here, to the power of 3. Enter. 1.3824 times 10 to the 7th. Pretty amazing. Okay. So let's do the square roots. So if we had a square root of 16 times 10 to the 4th, right? This is square root of 16 times the square root of 10 to the 4th. Square root of 16 would be 4 times 10 to the 4th. Well, 10 to the 4th square root. There's a 2 here, the index. So it's 10 to the 4 divided by 2. This 2 goes here. 4 divided by 2 is 2. So 4 times 10, 4 times 10 squared. 4 times 10 to the 2nd power. Let's do that. This problem wouldn't be given to you because this decimal would have been moved over. I'm going to show you in a little minute what we can do. So here we'll take the square root, so 2nd square root, and then we'll go 16, E, 4, and then enter. 4 times 10 to the 2. What would be the problem, what the original problem here would have probably been something like the square root of 1.6 times 10. If I make this number smaller, I'll make this bigger. Would have been something like this. The thing is, this is an index of 2, and 2 doesn't go into 5 very easily, so this 5 would have to been changed. And when we change the 5 to a 4, then this would have changed to a 16. Because if I make this number bigger, to make it 16, I have to make this number smaller. So it's a strategy, especially if you're doing this by hand. So for example, let's say we would take in the square root of 0.81 times, this is different, times, let's say 10 to the 6, right? Well, this is square root of 0.81 times the square root of 10 to the 6. The square root of 0.81 is 0.9. It's like the square root of 81. And this one 10 to the 6, right, square root, an index of 2. This 2 is going to go down here. So 10 to the 6 over 2, 10 to the third. So times 10 to the third. But this decimal is not in the right place. We need it in the ones place. So we're going to move this over. We're going to make this bigger, this number bigger by moving the decimal over. And we're going to have to make that smaller. And is that the answer? Well, we'll find out. Take the square root of 0.81 to the power of 6. Enter. 9.0 times 10 to the 2, or 9 times 10 to the 2. Okay. So the secret here is that this exponent, right, needs to be even so that you can easily have an integer. So most of these problems will turn out nice. Of course, there are situations where you don't know the square root of some number, and if they let you use the calculator, then it'll be much easier to do, of course. So if you like this, if you like this content, if this was valuable, please tell your friends. Please give it a thumbs up and show it to your teacher. Maybe your teacher will put it online. All right, I hope you have a great semester. I'll see you later. Bye-bye.